Hello, everyone. One of the students in your class asked me to help with the balancing chemical equation, and I have some equation on the screen that I'm going to work out. The main point for balancing chemical equation is the following. You need to make the same number of mole on the reactants and the product. On this reaction, let me get my pencil. Okay, on the left side, always you will have the reactants, and after the arrow, you will have the product, right? So I'm going to start with the nitrogen. Why I'm starting with the nitrogen? This is a tricky thing that you need to keep in mind. When you do the balancing, always start with any substance different than hydrogen and oxygen. That will help you to balancing fast. So remember, on the left you had the reactant, on the right you had the product after the arrow, okay? So let me erase that and going back. I will start balancing with nitrogen. I had two nitrogen on the left and I only have one nitrogen on the right. The easiest thing will be writing a 2 here and that will make two nitrogen on both sides. But by writing the 2 on the right side, now I had to multiply 2 times 3, so I have 6 hydrogen on the right. And I only had 2 hydrogen on the left. So you have to multiply this one by 3 to make equal to 6. So I'm going to place a 3 here. And finally, I'm going to count again. 2 nitrogen, 2 times 1, 2 nitrogen, 3 times 2, 6 hydrogen, 2 times 3, 6 hydrogen. So this equation is already balanced. You don't have to write the one, probably in some textbook or online video, you will see that they write a one in front of, by default, if you have one, you don't have to write the one. The other thing that I want to mention about balancing is the following. Never ever try to modify the subscript, the number that are here, below here, this number. Never ever balancing by changing that number because that will change the whole stoichiometrical combination of the atom. Let me try another one. Okay, I'm going to try the second one. On the second one, you have one potassium on the left, one potassium on the right. You don't have to do anything with the potassium. One chlorine on the left, one chlorine on the right, nothing with that. But then you had three oxygen here and two oxygen there. How can I make them both equal? Well, you need to remember the minimum common multiple for math, and that will make equal by multiplying the whole. If you multiply by 2, you will get 6 oxygen on the left, right? And if you multiply this by 3, you will get 6 oxygen on the right. So I'm going to place a 3 in front of the oxygen, having 6 now, and a 2 here. But by adding the 2 in front of the potassium chlorate, you are modifying now the potassium and the chlorine. You have now two potassium, so I had to put a 2 here, and you also had 2 chlorine, and because I already placed the 2 in front of the potassium chloride, you have already the 2 chlorine on the right. I always do the following. I always double check at the very end if I have everything properly balanced. So I do like a final count of the number of atoms and multiplying the stoichiometrical coefficient 2 times 1, 2 potassium, 2 times 1. Why 1? Because it's only one potassium. You never write the 1 as a subscript, but if you have one uh, symbol of the element, it will imply that you have 1. So we had 2 potassium, 2 chlorine, because I had to multiply the coefficient by every single one that I have in the formula. So 2 times 2, yes, 2 chlorine on both sides. And now let's count oxygen. I have 2 times 3. Why 3? Because the subscript is 3, so 2 times 3 will make 6. 3 times 2 will make 6. So it's already balanced. So I'm going to try now the next one. I have one sodium on the left, one sodium on the right, so I don't have to do anything so far with the sodium. I have one chlorine here and 2 chlorine here. Well, I need to do something with the chlorine because I had 2 here and only 1 here. If I multiply by 2, then I will have the same number of chlorine on both sides. By doing so, I have 2 sodium on the right now, so I will place it 2 here because this 2 is affecting the sodium and the chlorine, so I had 2 sodium here. Next, fluorine. I had 2 fluorine here and 2 times 1, 2 fluorine on the right. I think it's balanced, but again, I always do a final count because I go step by step and maybe I miss a one, so I'm going to do a final count. And this is something that I always do. 2 sodium, 2 sodium, 2 chlorine, 2 chlorine here, 2 fluorine, 2 times 1, 2 fluorine. Yes, it's already balanced. Let's try number 4. Number 4, you have hydrogen and oxygen, so you need to try. Anyways, you have to pick any ones. I always start with the left one. Hydrogen, 2 atoms here, 2 atoms here. So far, so good. Oxygen, 2 here and only 1 here. So I have 2 oxygen here and 1 oxygen there. So I'm going to place it 2 in front of the water so I can have 2 oxygen. And by doing so, now I'm affecting the hydrogen because this 2 is also being multiplied by the subscript of hydrogen. So now I have 4 hydrogen on the right and only 2 hydrogen on the left. Placing a 2 here will make 4 hydrogen because I'm multiplying 2 times 2 make 4. Let's do a final count, and that will be okay, 2 times 2 for hydrogen, 2 times 2 for hydrogen, 2 oxygen, 2 times 1 is already balanced. Let's try the next one that looks a little bit more complex. 1 left on the right, on the left on the reactant, 1 on the right. Let me repeat that again. Reactant will be always to the left of the arrow. This is the arrow, and product will be on the right. Okay, the next thing I want to check is, I mentioned this is a tricky thing. You keep working with anyone different than oxygen and hydrogen. So I'm going to skip oxygen and hydrogen for now. I'm going to balance chlorine. I had 2 chlorine here and only 1 on the left. I'm going to place it 2 here, right? And that will make 2 chlorine on the left and 2 chlorine. This is just a tricky thing for speeding the balancing. It's not like you can do oxygen and hydrogen, but sometimes it will be taking longer to balance. That's all. But you can start with oxygen and hydrogen without any trouble. So now I'm going to start with the oxygen. I have 1 oxygen here that is with the parenthesis having 2. So 1 has to be multiplied by 2. So in total, I have 2 oxygen. And here we have only 1 oxygen. So I'm going to place a 2 in front of the oxygen here. So far, so good with the oxygen. Let's count hydrogen. I have 1 atom of hydrogen being multiplied by 2. So that will make, let me erase so I have more room because I'm writing on top because I already balanced the rest and I don't need to have all this writing here. So what I'm going to do is I'm working now with the hydrogen. I had 2 hydrogen here and 2 times 1 two more on the left here, because I placed a 2 in front of this and I had 2 here. 2 plus 2, of course, that will be 4, and 2 times 2, that will be 4, and that's already balanced. Let's do a final count and see if we get the whole balance equation now. And that will be one lead, one on the right, uh, two, one times two, two oxygen, two times one, two oxygen, two hydrogen, and two hydrogen make four, two times two make four, two times one, two chlorine, two chlorine. It's already balanced, that equation. So that will be my way of balancing. Let's check the next one that is a little bit more complex, and that will be, I have on the left one aluminum and two aluminum here. So I'm going to place it two here right away. So I have two aluminum now and two on the right. And then I will continue with the bromine. 2 times 3 will make 6 bromine here, and I only have one here. So I'm going to multiply that one by 6, right? So that will be 6 bromine on the right. Then I will continue with the potassium. I had 2 potassium here, 2K, and 6 on the right. So in order to make equal, I had to place a 3 here. If I multiply this by 3, I will get 6 potassium, right? And then that's another tricky thing. I can count the whole sulfate as a one unit. You can count sulfur and oxygen, but based on the product, it will be easy if I say 3 times the whole thing here, sulfate. 3 times, you see the script here, 3 times sulfate. I don't have to do anything with the sulfate because I have 3 times the whole thing. If you want to count one by one, it's okay. 3 sulfur, 3 times 1, 3. 3 times 4, 12 oxygen, and 3 times 4, 12 oxygen. So you can do one by one or grouping the whole thing. Maybe for starting the practice will be better if you count one by one rather than grouping, because by sometimes you have to know which one you have to group. So let me double check at the very end, like a final check, making sure everything is balanced properly. And I'm going to count every single one. And that will be 2 aluminum, 6 bromine, 6 bromine, 6 potassium, 3 times 2, 6 potassium, 6 potassium, 3 sulfur, 1 times 3, 3 sulfur, uh, 3 times 4, that will be 12 oxygen, because you have to multiply this by this, and this times this, that will make 12. It's already balanced. The next one will be methane plus oxygen, 1 carbon, 1 carbon, 4 hydrogen, 2 hydrogen. Placing a 2 here will make 4 hydrogen. And now I had to count oxygen. I had 2 oxygen on the left, and on the right I had 2 oxygen plus 2 oxygen, because this 2 is also affecting this one. In total I will have 4 oxygen. So by placing a 2 here, that will make adding 2 more oxygen, and that will be 4. Final count, double checking that everything is already proper balance. I'm going back and say 1 carbon, 1 carbon, 4 hydrogen, 2 times 2, 4 hydrogen, 2 times 2, 4 oxygen, 2 and 2 times 1, 4, balance. Next one, 3 carbon, only 1 here. I'm going to place a 3 in front. That will make 3 carbon on the right. Then I can continue with the hydrogen. 8 hydrogen on the left and 2 on the right. So if I multiply this by 4, I can get 8 on the right. And now I had to count oxygen. I had 2 oxygen on the left, and I had 3 times 2, 6 oxygen plus 4 times 1, 4 oxygen. That will make 10 oxygen. In order to make 2 equal 10, this is a 10, no oxygen, 10 oxygen. In order to make 2 equal 10, I had to multiply this one by 5, and 5 times 2, if I multiply this, 5 times 2 will make 10. And let me do the final check again, and that will be 3 carbon, 3 carbon, 3 carbon, 8 hydrogen, 4 times 2, 8 hydrogen, 5 times 2, 10 oxygen, 6 oxygen in carbon dioxide, and 4 oxygen in water. So 6 plus 4, that will make 10. Again, the next one, 8 carbon. I only have one on the right. I will place an 8 here. And then I had to, balance the carbon. 18 hydrogen. I only had 2 here. So if I multiply this by 9, 9 times 2, that will be 18. And final count will be 2 oxygen on the left. And on the right, I have 8 times 2, 16 plus 9, right? And if I do my math properly, that will be 25, right? Because that will be adding 16 plus 9. Okay, that will be 15, carry 1, 25. Yes, it's 25. So how can I make 25 oxygen equal to 2? Well, that's a tricky one. I probably need, because I don't know any number that you multiply by 2 that will give me 25. Easy way. That's a tricky thing that you probably need to learn. I'm going to write 25 over 2. Here is easy way, okay? 25 over 2, a fraction. Okay? That's another tricky thing sometimes when you are doing a combustion organic reaction, you can use fraction. And if you count, it's already balanced. 8 carbon, 8 carbon, 18 hydrogen, 9 times 2, 18 hydrogen, right? And oxygen, I had 25, I had 16 plus 9, and that was 25. But we don't balance, we can balance using fraction, but we don't express the final result in fraction. How can I fix that now? Okay, I will multiply the whole equation by 2. Why I do that? Because I can get rid of the denominator. Once I multiply the whole equation by 2, I can get rid of the number dividing 25 here. So that will be 2. I'm just doing the multiplication now. If I multiply 25 over 2 by 2, it will be 25 only. And then if I multiply 2 by 8, it will be 16. 16 here. And if I multiply 2 by 9, that will be 18, right? 18. Let's now remove the 2 that I used for my multiplication, and let's count again. 2 times 8 will be 16 carbon. I have 16 carbon here. 2 times 18 will be 36 hydrogen. Let me write here. 36 hydrogen on the left. And I have 18 times 2. That will be also 36 hydrogen. Let me write down here 36 hydrogen here, because I multiplied 2 times 18. And if I multiply 2 times 18 times 2, that also will be 36. 25 times 2, that will make 50 oxygen. 50 oxygen. Let's count the one that I have here. 16 times 2, if I do the multiplication right, it will be 32 oxygen. And I have let me use the 32 oxygen on the right, and then 18 times 1, 18. Let's see if I can add them together and get 50. 10, 2 plus 8, 10, carry 1, and that will be 4 plus 1, 50. Yes, I got 50 oxygen on the right. So the equation is balanced. Notice the tricky thing that I did. I place a fraction first, and then after placing the fraction, I just get rid of the subscript or the denominator by uh, dividing by 2. If you have a denominator that will be 3, you have to multiply by 3. If you have a denominator 5, whatever number, you multiply the whole equation by 5. And that happens very often in organic chemical reaction. Finally, number 10 will be iron chloride, iron 3 chloride. We have one iron, I don't have to touch the iron so far. We have 3 chlorine, but we have only one here, so I'm going to place a 3 here. And then because I placed a 3 in front of sodium chloride, I had to place a 3 in front of the sodium hydroxide. So let's count now everything. I had 3 oxygen, 3 oxygen, 3 hydrogen, 3 hydrogen. Let's do the final count. One iron, 3 chlorine, 3 times 1, 3, 3 sodium, 3 sodium, and then 3 times 1, 3 oxygen, and I had 3 here because this subscript here is affecting the one here, so it's like a multiplying 1 times 3, and 3 hydrogen and 3 hydrogen. And that's the way we do the balancing of chemical equation. And that's all I have for you today. I hope that will help you to do the balancing. Thank you for watching.